Hello, welcome to tutorial 19, and we're making some kind of version of Minecraft in Python with a panda and made by the made with the Ursina engine made by Petter Amland. I just realised I need to switch down the volume a little bit. Okay, so this is where we got to last video. If I open up the inventory, let's get some grass on there. Some ruby and some emerald, I think I called it. And then if I press 1, I can build with grass. 2, I can build with rubies. And 3, I can build with these guys. Emerald. But what happened was, how did we get the ruby to go white? I've forgotten now. Oh, that's right, when we mine, the ruby goes white. So when we mine things, we get a little collectible. But the coded materials, a couple of videos back, which we make on the config file, because we're not deriving their color from the texture, but via the code, we're getting a white light through. But we can change that in the code. But I'm not going to get to that straight away. What I think is more important is the behavior of picking up these collectibles or collecting the collectibles. If we go over them, we want to hear a little noise and then collect them. And the other important behavior, which I'm guessing I won't get to in this video, but you never know, is if, let's say, like on the inventory now, I've got some ruby already and I go and collect some ruby, then we shouldn't get another ruby icon somewhere, but a number should be incremented on the inventory. So in other words, we've got to get some text working on the screen. In fact, in testing and preparation, I have got text on the screen, but I haven't developed it for that kind of system, but potentially we can do that. So first, the first big job is getting pickups, picking up collectibles collected. I just had a little voice in my head saying there's a couple of things to get to. I remember one of them was the player's height isn't quite right. Let me just show you what I mean. I think we left a note. So I've just gone to the mining system module. And there we go. Yes, in the highlight, the very important highlight function, which controls which block is being highlighted when we're looking at it. And we do that in this for loop. And we're looking like 32 blocks ahead in Minecraft. I don't know, it's about 7, something like that, maybe 10. I'm not sure. But I've done mine 32, so we can mine really, really far away. But that will slow things down. So here we've just hard-coded in 1.86, which is something like 6 foot. But we want to say player's height really there. And so the only information we're getting about the player passed in as a parameter or as an argument into the highlight function is the position of the player, the camera object itself, and the terrain dictionary. So what we want after the player's position, we also want the subjects. I'll call that sub h. There we go. Lots of underscores. Sub h. Well, you know what? Since none of these other parameters have got underscores to begin them, I'll stay conventional with those guys. So sub h. Okay, so highlight is called by the mesh terrain module. So let's go into the mesh terrain module. And there it is, the first line, in fact, inside the update loop. We're not passing in the subject's height, but I think we do have a handle on the subject in this module, in this class, I should say. Yes, the first member property that we've got is member variable is a subject. So let's go back down to highlight, update, sorry, and then into highlight we can write as a second parameter this dot subject dot, and then we went want to write height of the subject. Now if we just go back into the mining system, we need to use that sub h, so I'm just going to copy that, and we can pop that there. Beautiful. So now if we change the subject's height somewhere else, we only have to change it once. We don't have to track where it's being used. Good. I don't think we use it anywhere else. Okay, so now if we go and save that module, save mesh terrain. I'm also kind of like looking at the this note we've left ourselves. We don't need to pass in position and camera anymore, because up at the top, yes, we are, when we create our terrain object using this class, we are passing in the subject and the camera, which means we don't need to keep passing them in down here in update. We've got them already, so we can delete those two parameters, but we do need to write in this dot subject dot position to replace that, and let's put these on different lines so we can see what's going on neatly. And camera as well is now called this dot, was it just cam or was it camera? Nope, camera. There you go. So we've already got those, so that should be more efficient and tidier. Okay, so I can delete that message to myself. That's all nicely together. So let's just go to main and just check that we have got a subject height. Yes, so there we go, subject height 1.86. And look, when we create our terrain using that mesh terrain class, which constitute the mesh terrain module, which I've just gone back into, there it is. Back to main again. We pass in the subject and the camera. So the subject will include all of this information, so we have access to within mesh terrain. So now, since I'm in the main function, let's run what we've done so far and just check that we haven't broken anything. We should have exactly the same behavior. Oh, and we have broken something. Update takes one positional argument, but 3 were given. Didn't we just? I'm sure I sorted this in. Oh, main update. Right. I see. So the corresponding call in the update function of our main module, that's where we're passing in subject's position and the camera, which we don't need to do anymore because we've already passed it in at the beginning when we initialize our mesh terrain. Okay. So I've saved that, save it again, press play. Good job we're doing these checks as we're going. There we go. I'll press G to turn off the terrain generation, so it's nice and smooth. 60 frames per second. And I can blister mine, I can create my collectibles as usual. I can run over the top of them, but I can't collect them. So that's the next thing. And also, can I? Yes. When I'm looking at different blocks, I'm looking exactly at them. Now, I did a little bit of, I actually did some research and I found out that the height of our Steve from Minecraft is, or the eye level to be precise, is 1.62 units. So let's change that to 6.2. And I'll put a little note, whoops, I'll put a little note here. Minecraft eye level, question mark. That's just reminded me of the other thing that I had in my mind before I go and test that and have a look at it. Look at this word, expires. Isn't it just expires? Yes. Right. main run. Does this look closer to Minecraft? Of course, we're not necessarily reproducing Minecraft exactly. So you can have your player's height, whatever you like. And of course, I haven't tested extreme changes, so there will be things that break in terms of the bump collision and things. But that's all a fun adventure to go and debug that. Which I recommend. There we go. Yeah, this looks... I don't know. The blocks feel wider in Minecraft. Maybe it's because there's a higher resolution in Minecraft for the textures. Is that right? I'm not sure. It just doesn't quite feel the same. The blocks seem larger in Minecraft. I don't know. Really, what I need to do is just take some screenshots of similar situations and then have a look. Oh, I know the other thing I had in mind I didn't write down is if I went to hotspot number 5 on the hotbar and now build, I can build. I shouldn't be able to do that. So let's just go and sort that out. So, here we are. So, we'll do this later, the number 1, color bug. Picking up behavior is the main thing. You know what? Let's write 0 was eye level correction. We've also done 0.1. We did the more efficient highlight call. That's without passing in subject and position all the time. That's done. Now what are we working on? We're working on, oh yes, 0.2. That's going to be the empty subject hands, then no build. Okay. So in main, we've added that, haven't we? Yes. Subject block type. There we go. Let's just add a little comment, actually to the end of the line. Current building mineral. So basically, that will be set to none if we've selected a hotspot that has no item in. So when we're trying to build, that'll presumably be in the building system or mining system. Let's go to, well, it shouldn't be in here. Let's go into the mining system. Yeah, it's not there. Mesh terrain, perhaps. So that's do mining, generating walls, generating a block, generate terrain. Oh, so perhaps it is just in the building system. So let's view Explorer so I can see my modules and building system. Oh, that's the bump system. Building system. Thank you, Explorer view. Can't build here, sorry. Check build. Now, do we want to ask the question here, is the subjects, excuse me. A little tired. We don't have access to the subject in here. So what module is calling check build? I think that's mesh terrain. Called from mesh terrain. By the way, smiley face, just leaving a comment for ourselves to help us negotiate our modules. So in mesh terrain, that would presumably be in input. Input, there we go. Building, right, build site. So again, this would be better placed within the building system. So I need to build this, ironically, or organize this in a better way. And that organization will be to do with which modules have access to the subject and so on. Anyway, it's quite nice and small and contained here, so that's okay. So if well, just under here is building. So we could, before doing any of this, we could just say something like, well, if this subject's block type is none, then return. First, return and don't build if empty-handed. So that's what we've just done. So if our block type is set to none, then empty-handed. And indeed, main, we should start therefore with block type being none. Let's see if we can break anything by doing that. Okay. Interestingly, we have got some minerals, some items on our hotbar, and ice is in position 1. But I don't think, because it's not highlighted yet, it's not actually set as what we're controlling. So maybe we need to also instigate that as well within the inventory system. But anyway, it's not crashed yet. We can still mine. Very good. And if I press right button, brilliant. Our return prevents us from getting to the build part of the code that we were just looking at. That's what return keyword does, if you didn't know, or if you haven't seen my previous videos. So it just returns or escapes from that function, doesn't run what's underneath it. And the condition for that happening was our block type, our subject block type is none. So if I press 1 now, that from I think last video meant that we look at position 1 on the hotbar, look at the item there, see its block type, and then populate the subject's block type with the same block type. So now if we build, yes, oh, I just noticed, let's just go to 2. I just noticed that my mouse is slightly in the wrong position. Look at that. Oh, I've got an idea for why that is. Well, one idea is, or one ingredient of what's going on is, of course, we've just changed the subject's height. So we've changed something, but to affect the code, the behavior, but our code looked fine because we tried this with exactly the same height, i.e. 1.86, and nothing, there was no problem. So what's going on, I believe, is 1.86 was close enough to the camera's pivot, i.e. the place from which we're actually pivoting our mouse, our kind of like eye pivot. So the previous height, 1.86, was close enough, presumably to 2, to match what was happening behind the scenes. So in other words, we just need to say camera, or is it subject.camera pivot? Subjects.camera pivot, there we go. And no, we use Y, there we go. Y equals, so this is the height of the camera pivot, and it wants to match the subject's height. So here, we don't want to write 1.62, we just want to write the variable subject.height. So we just need to change that number once there. Right, let's just go and see if that solves our problem. If it doesn't, I don't know what we're going to do. Oh, I'm kind of on this block here, aren't I? And it's skipping through. There's still something not quite right. Oh, I thought I had it all perfect. I can get to that one. I can get to that guy. Oh, the now the height has actually changed, and this feels just like Minecraft actually. Yeah, this is close to Minecraft. Oh, and if I get one, I can build. Good. Okay, so I have to think more carefully about the subject's actual height. So the subject's height, describing how tall we are right up to the head. But the pivot, okay, that is... Well, there, we're no longer... If I put it there, I'm no longer apparently looking at this block here. When I cross into this guy, I'm not quite on it. So there's like a little margin between. It's more than playable. You would hardly notice it, but it's not perfect and we need to conquer it. However, I must say, because now we're adjusting the height via the camera pivot, we're getting the kind of the perspective that we want and the kind of control that we want. Anyway, that's done, but I'm not perfectly happy. So we can leave this note in. If we can hit perfection one del, still not quite perfect. Still not quite perfect. And then like an O face. Oh, right. Save that. Any ideas about the getting that perfect? You can leave your ideas in the comments or on the issues page for which is on the GitHub repository. There's a link in the description to that. Right, now down to the main business, which is picking up those collectibles, as I'm calling them, like the mini blocks that are generated when we do some mining. So let's go into our collectible system. Right, so we've got a list of collectibles as we generate them. So we've got a function called drop collectible, and look, we append a collectible to that list. We've also got a bounce function, or collectible bounce, and we add some rotation, a little bit of a sine wave to it as well. And that's about it. So we want another function, like maybe collectible bounce, that iterates over all the collectibles and compares the player's position to the collectible's position, which I think we store on the... Do we store that on the... Yes, on the collectible dictionary. Well, at the moment, all we're storing on it is the block type. Oh, so we could say if the block type isn't, or if there is something, there is a collectible at this key, which will be a tuple, a vector 3 of x, y, and z position, then yeah, we can pick it up. And that will involve, what that's involved to decompose that process, that will be destroying the entity, because here each collectible is an entity, so we need to destroy that, not just make it go invisible, but destroy it. So we save our memory, and then because we're using a list, we want to remove it from that list. And look, we've got it, its block type stored on the dictionary, so we need to remove it from the dictionary. Now, we're using a list and a dictionary when they can do a lot of the same things. The question is, can a dictionary, which is faster, do everything we need a collectible to do? So we need to be able to delete it, remove it, we can store information on it. I don't think we need this collectibles anymore. What we want to do is CD, we want to record the block type and the collectible. In fact, what we want to do is put all of this into its own class. Okay, so let's try and build that up at the top. We're going to refactor this. So we're 25 minutes in. We're making some headway. So class collectible. The collectible class. Yes. I'll call it collectibles. Collectible. So first of all, it wants to inherit from entity. So we just pass entity in here. Oh, wait a minute. Let's go and have a look at another module, so I remember how to write this properly. Yeah, so good job I tried. Good job I did do that. And indeed, let's go to the inventory system where I know I've done some inheritance. Actually, I wasn't too far off. Yes, we put in brackets the fact that we're inheriting from entities, so everything an entity can do, the hotspot will be able to do as well. Lovely. So we've done the same thing there, and then we initialize this way, the double underscore or dunder, and then super initialize, and then we go. Okay. Double underscore init, passing the keyword. Well, traditionally, as I always say, self is what you'll see in most Python modules. I like to use this. That's where we initialize the object, in this case a collectible, and then we want to use everything that's initialized for the entity. So we use super keyword, and then I've forgotten. Oh, I forgot my syntax. No, I was just looking at it. Inventory system. Oh yeah, init. There we go. And then do I need more brackets like that? No, like that surely. No, just like that? No, no, it's not like that. That looks horrible. Oh, it's just with the brackets. Oh, right, because we're not in another indentation block. Okay. So this means, although we're writing our own initializing function, we don't want to overwrite the previous one that belongs to entity. We want to have everything that it's got. So every time you write your own function, that will supersede or overwrite the class from which you're inheriting. So if you use super, it just says, oh, go and grab all the other stuff, and then we can carry on adding more things. Okay, I think I made that fairly clear. Right, so in here, we want a collectible oh right, we need to give it a model and this guy and use deep copy. So that's the first thing we can put in, but because we're now writing a class, we need to use this keyword. So this model equals load model, that you deep copy, lovely, that's done. And then this texture equals, and that was text, a text parameter. So we need to pass that in to drop collectible. Okay. Or to this underscore text. So in the initializer, we need to pass in underscore text. Good. Then we're going to set these properties. So everywhere we've got a C, basically we just need to change to a this dot. So its scale is a third and its position is pos. I'm finding this quite therapeutic to build this up now. I think because we've got a roadmap down there, we've got a structure, a list of things to go through. Okay, this position equals underscore pos, so I need to pass that in after the texture pos. Actually, when I do it, it's block type pos and texture, so let's in fact copy those parameters in that order and put them here. Now again, the difference, because we're writing a class, the first parameter of every class function will be the this keyword, and that's just a keyword referring to the specific instance of the object we're creating. So lots of collectibles will have their own reference, self-reference. What we do want to do though, up here in like the neck, I don't know the official term in Python, in the neck of our function, before the initializer, we kind of, if we place it here, we're signaling to Python that we want this to be a static or a class function, class variable. Here is where presumably we will have the dictionary. So I'll call this CD equals, and that's empty. There we go. So to get hold of that will be, you get the collectible class dot CD. There you go. Now this won't have the this keyword. We're not creating lots of instances of the dictionary, just one for every collectible class that we create. Oh, so I can keep that there, that's fine. We use the curly brackets to signal that it's a dictionary. It just means, yes, later on we need to refer to this dictionary. Okay, so let's carry on working through. So indeed, we need to now say, we need to write to the terrain dictionary. No, we don't. The collectible dictionary. So record my position on the collectibles dictionary. But it isn't CD, it's collectible.cd, and it's not C position, it's just this position. I could use underscore pos here. I feel more comfortable inheriting from myself there. And the block type, oh right, which we write to the dictionary. Now we're gonna have we want to, yeah, we want to record a tuple, so we'll record the block type. It feels better, we should actually just give it a block type. Yeah, let's try it that way. So we'll say before we do the dictionary, in fact, but these variables kind of belong together, like the basic model and position and things. So they're already variables that belong to any old entity. But now we'll make our own ones and we'll call it block type. And that will equal block type. So it just means on the terrain, not the terrain dictionary, the collectible dictionary, we're going to record me on the collectible dictionary. Key is my position. And so the me and the my is referring to every little instance of a collectible that gets dropped. I'm going to record itself there equals this. There you go. So it refers to this object, or an instance belonging to this class for this collectible object. Okay, that makes sense. What else do we need to do? Then we were going to print its position to the console to make sure it's working, but we're not going to do that. But we do need to center its position. Oh, at the center of the mining site, so it's not on the floor. I remember that. We need to keep its original position. Give it an original position. Let's do these one at a time so that we can deal with the sign bounce. The sign bounce refers to relates to its original position. So where we've got a C dot, we need this dot, its height. Add half of a block's height minus half of our scale. Good. Notice that because we're changing the position here, we're doing this after we record our or use the position as a key for the position of our collectible, because if we adjust it here, it's not going to be exactly where our player might go. So our player and this collectible will be like floored and rounded down, which I might have to do there. No, I won't, because it's already rounded down. Its position is going to be derived from the build tool entity's position, since we're mining. Yeah, good. So now it was yes, we need to give it an original position. In fact, we can do that up here, under block type. So it belongs with the right kind of member variable. So its original position equals this dot y. Oh, original y position. And I've already commented that's for the sign bounce. Then we do the texture stuff. And the UVs derived from the block type, that's fine. And we build that up. Oh, so I just need to change these C references. And we don't need to append it to the collectibles list because we've already appended this object to the dictionary. And it's now a class dictionary. So let's paste all that in. Make sure it's indented correctly. And change our C's to this dot, this dot, this dot, this dot, and there's one over here in our list comprehension. So that phrase just means building a list with like an embedded piece of iteration. This little for loop for U in C model or this dot model UVs. So it goes through all of the UVs, this little list here, and builds up a new list within this one line. That's called comprehension. Done. Okay, I'm tempted here to try and sort out the colors, which looks very similar. So this code is borrowed from Mesh Terrain. So if I go to Mesh Terrain and it's something like within build block, generate block, there we are. So this is where we're building vertices and we're giving it a random color. Now if the length of the mineral's block type is greater than 2, then grab the color data. So that's what we're missing. We're not grabbing the color data from that config file. Let me just remind you of what on earth I'm talking about. Okay, so I haven't got that open. Let's view the Explorer. Let's have a look down here. Where is the config file? There he is. So on the config file, our minerals dictionary, you can see it's a dictionary because we've got the curly braces. We are storing the UV data here. So these are the coordinates on our texture atlas for all the different block types. And for ruby and emerald down the bottom here, we're not just recording the coordinates. The third element, which is very big, is a vector 4. So that can store 4 elements within itself. And these are colors. So RGB and then the transparency. 1 just means fully opaque, can't see through it at all. So the emerald, that's why the emerald is slightly see-through, because we've got 0.8 there. And for emerald, we're saying no red, quite a lot of green, 80% green, and a little bit of blue, 10% blue. And for ruby, it's just 100% red, nothing else, fully opaque, as we said. So that piece of data there is at position 2 on the index. The 9 is 0, 6 is 1, and therefore the vector 4, or the color, is at location 2. So that's why in mesh terrain we're asking for grab the vector 4 color data at position 2, and we're referring to the block type because the block type is the key for getting these out of the dictionary. So we should be able to just grab that from here, copy and paste. Now, what if we've got something like the grass block, which doesn't have a length greater than 2, i.e. it's just got 2 pieces of data. Let's have a look at the grass block. On the dictionary, we've just got an X and a Y position, the UVs for the texture. So then what does it do? It decides a random color, random tint, and we're in else. It just grabs a random tint and then it just adds the colors on. So CE is the color data, if you have got some color data, and then C is just the random tint. Great, so let's just grab that. And it has to happen before we extend the UVs, or it does here anyway. So let's grab that with the comments, go over to our collectible system. So before we sort out the UV information, we'll attend to our colors. Is that all indented correctly? Yes, somehow yes. So where we've got block type, we need that underscored. C, we won't get a random. Oh, okay, let's have a random color. So we haven't got random. Can I get that from math? Oh, and actually, let's take off math from Ursina and say from math import sign. We'll go down to the sign function call down here. Now we can just write sign. There we go. From math, can we also grab, what was I just doing? What on earth was I just doing? Random. No, it's not random. From random, import random. Yeah, so confusingly, from the module, there is a function called random. Is that right? Yes. We had some problem actually using random in a different module. So if something goes crazy, I have to do something else. Well, in fact, let's call this rar. No, okay, let's just do it as it is. And then if we have some crazy thing happening with the colors, we know it's because of this random, or we can suspect it's to do with this random call. Anyway, let's change what we need to change. So block type needs to be underscored. Vec4 doesn't appear. So from Ursina, we can get a Vec2. We can also get a Vec4 comma, and I've placed this next to vec2 because they seem like friends. Put them there. Back down here. So model.colors. So we want to refer to this dot model because we're referring to this dot model here. We're writing a class. This dot model colors extend vector for CE. So CE variable is already worked out. None of that we have to change. This dot number of vertices. We haven't worked that out from the model. So we need to say this dot num vertices equals the length of this dot model dot vertices. And that should count the length of the list of vertices and give us the number of vertices that we've got, which are just the corners, the points in our model. In fact, I know that kind of logically goes with the model there, but because it's one of these variables we created ourselves, let's put that with that group there. Okay. And did I write that correctly? This num vertices. Okay, that's gone nice and blue. It's spelled the same way, I think. So that's good. And we've done that one down here. So the last thing I think we need to change there is this dot model. So we're referring to this objects or this instances model, this num vertices, and then everything's done. We should have the correct colors now. And I want to go and run this straight away just to check that, but we've written all this into our new class, which we haven't even created one collectible using this. We're updating our code, refactoring it, but there we're adding something new to it. Then we just need to generate the model. Oh, there we're kind of done. I think so I've got that in generate. We're ready. Let's just add a new comment. Done. Build me. So the initializing function, we just need to drop in the block type, the position, and the texture. And boom, we've got a new collectible, and it will write itself onto the, and actually I'll make that its own section. It will write itself onto the dictionary. Great. So now what we can do is write an easier function. This collectible bounce function should be a lot simpler. It should be just this code here. We don't need to iterate over all of them. They're all going to be iterated anyway. Okay. This is like you'll now see the point of doing all this, because partly you'll be thinking, well, is this just going to do what we could already do before? What's the point in being more organized? Now we've got one advantage. So we're going to define a new function, and that's going to be update. Now, because we're deriving, or inheriting, I should say, from the entity class, there it is. So every collectible is also an entity. It will have an update function. And if Ursina sees that you've got an update function here, it will run that automatically every frame. So we don't have to call this anymore, which means I think it's going to be in the mining system, in highlight, we should certainly look after this behavior in a dedicated collectible class. That's exactly what we're doing now. So we don't have to run this. Whoops. And we shouldn't do it here, because this is about highlighting a block. It has nothing to do with collectibles and making them bounce around. So if someone's going to improve this code, they would struggle to find it inside here. So that's a bad place to put it. So we've commented it out, and we've left this as a pure function looking after highlighting blocks. Okay. So back to our collectible system. So in update, we want to make our own function called bounce. And do I have, I think I have bounce. I think I have to call it this dot bounce. And in fact, this then wants to be inside bounce. So def dot bounce this, and now put in this code, and instead of a C, we want this dot. So this item's rotation increase by 2, and then add a little sine wave. This dot rotation divide by 50. Is that the same as doing 0.05? Something like that. Let's change, so from a division to multiplication. Multiplication is optimized. It'll be easier for the computer to do. There we go. So again, I could have just put all this, as I started to do, inside the update loop, but we might want the collectible to do other things than bounce. So it'd be nice if we had a list of things that said bounce, change my color, and then it all makes sense. And the bouncing behavior belongs in bounce. So it's easy to read the code now and to find bugs, such as me doing this. That's probably a bug. Like it's spinning way too fast or way too slow. And we've got the color. Okay, so now we don't need, we don't need any of this down here. So the only thing we are calling is drop collectible. So we do that presumably in the mining system, or actually we probably do that in mesh terrain. No, we do it in here. Drop the collectible. So block type equals whatever block we're looking at, and then drop collectible. Now we want to initialize a new collectible instance. So, okay, so we're importing everything from the collectible system. The only thing I'm a bit fuzzy with here, I'm not understanding from Python yet, although this process will help me understand, is where are we? The collectible dictionary is here, but if we haven't created a class, this will not exist yet. Anyway, let's just plug on and just see if it starts working straight away, which will tell us one thing. If it doesn't work straight away, it tells us another. So we're going to say can I just say collectible? Will that create a new collectible? I don't have to put it like in a variable, do I? Anything like that? I just say new collectible, please. And yeah, then I can just copy the parameters. Exactly, because they work in a very similar way. Why isn't texture like that, the same color? There's texture. Who knows? Who knows? Right. Let's try and run this thing. Go. Press G to stop calling. So, I was kind of feeling confident because it hasn't crashed, but, well, okay, that is one good thing. We haven't done any major errors in our coding, but the behaviors will only kick in when I try to mine. So let's try mine. Oh, it's working. This, more excitingly, is a proper collectible object via that class. So I clearly haven't. I've done something with that bounce code. Well done if you saw the bug happening live. And I was doing a lot of talking, wasn't I, and rearranging. So I probably missed something. And I can do another one. They are kind of cute when they swim like that, but it's. Oh, now I've said it, I kind of like them doing this. But maybe we can change that. They're kind of like jumping, aren't they, from the ground? We can maybe change it back to this when we find out what the proper bug is, so we've kind of earned it. Okay, great. So we're back in the position we were in before, but cleaner code. Great. Okay, so let's go to the collectible class. And you know what? I'm going to be very brave. I'm going to delete the previous code. Done. That's what GitHub is for. It's all there if I need it again. Right. Now, this dot y equals this original y. Okay, so this original y I put in the wrong place. Oh, okay. So this is a central place. So this needs to be after we've moved to the central position. Okay, that's done. Save and run. Oh, again, actually, I did want to test. Maybe there was something in the old code that I hadn't deleted yet that was allowing it to work. No. Okay, that's working perfectly now. That's so good. And we get the right types. Oh, something I didn't really see is if I build these guys, they should be the right color now. Oh my goodness, we've actually fixed a bug. Brilliant. Okay. I won't test the other colors. We can save that for later on. Great. We're in main. Let's just have a look at our list. We can say done. Empty subject hands, then no build. Yes, we solved that. That's done. Color bug fix. Done. Picking up behavior. This is the big behavior. Now, I've done this in the prepare code, or I've done a version of the prepare code. And I'm going to do it differently now because I didn't prepare a collectible class. That was done with you guys live for the first time. So it should be easier. Now that I've got this class, it should be easier to do. So what we want is another function on here for every single collectible. In the update, I told you there'd be a list of things. So first, we want to bounce you around. Well, actually, before you bounce, just check. Whoa, is the player colliding with you? So we call that check pickup. There we go, check pickup. Capital letter P, capital U. Check pickup. So we need that function to exist. So define check pick up. Now we need to remember this keyword as a first parameter and write in pass, which means do nothing until we've worked out what to do. So what do we want to do? We need to ask the question if, I'm starting to write code already, but if the player's position, which is going to be a key. So we need to say something like position or sub p for sub position equals, no, we need to get the x, y, and z from the subject's position. Like that. We could do it like this. And then we can say if the collectible collectible dictionary. We pass in the key there, which is it's a tuple, so it's x, y, z inside another pair of brackets. Get is not none. Is that right? It's almost like writing English. So if there is nothing there, i.e. if there's something, that should exist. Something should just exist. What about something? No. Is not none. You know what? That feels so much better. It's not none. Then pick me up. Pick me up. So to get picked, okay, let's just write got me. There we go. So we can test this first bit. So check pickup. We need the subject's position. So when we create a collectible, we need the subject. So the final thing we need is the subject. So with my custom member variables, we'll say this dot subject equals underscore sub, and then pickup. This will actually be this dot subject dot position 0, or y really, position y, no, position x, x, y, and z. Yes. So you might say, well, what don't we just need? Wouldn't it be a smaller data set just to get hold of the position? But that would be the position of the player when we first initialize, instantiate this object, this collectible. But then the subject might move away, and so where the position was isn't the same as where they are now. We need to keep checking where the subject currently is. So what we need is a reference to the subject entity itself, that object. And then we're asking the question down here, when we say this subject's position X, it's getting hold of the subject, and then it can look at its current position, which will now be this. And indeed, we want to floor this, I think. So we don't want your exact position as a floating point, we want it as a whole number, an integer. Floor doesn't seem to exist, so we'll grab that from math. So from our math import, sin, comma, we also want floor, please. So we can use that function wrapped around there. Great. And we're using that to build our key. We'll make a little note of that. Grab subject position to make a key, and then use key to wait a minute. Oh my goodness. I'm not thinking straight. I'm thinking through my old version, forgetting that I'm inside of a class. Look, this just means, do I exist? That's saying, is there a collectible at the position that the player is, And then we're going to use that to get hold of this object. All we want to say is this object's position? It's like original position, the same as that. Then again, we would have to create. Yeah, we kind of don't even need this because we've got the block type. Wow. Okay, let's try taking away the collectible CD. There we go. So for now, we will comment those out. And yeah, we'll keep this X, Y, and Z thing going on. But inside here, we'll say if, and now we'll create a new vec3, or just a new tuple. Can we compare tuples like that? Let's just try it this way. If X is the same thing as this dot X, no, we need its original position. We need, or would it be rounded down? Would it be floored as well? Yeah, okay, so its position, we also want its central position, but okay, so where we recorded it here, we want this dot O position equals this dot position. And that's going to be floored and rounded because its position is inherited from or taken from this parameter, which was the BTE's parameter, which is floored or rounded or whatever. Okay, so original position for checking pickup by subject. Okay, so that's in the initializer. Slightly confusing because we're kind of adjusting the positions and we've got this original Y with the sign bounce. So it's completely separate to that, but it's to keep it separate from that. And we have to grab that before we start moving it to the center of the block or wherever else. Okay, so we're not referring to down here, we're not referring to its X position, we want its O position. So let's try that. Let's just say, we don't need to create a new vector3 really, do we? We want to say if, yeah, okay, let's just comment those out and see if we can just say if this dot subject's position is the same thing as this dot O position, my original position, then you can pick me up. So, and that will say print got me in the console, just to see if that's working. And interestingly now, we're not using the collectible dictionary at all. But we've only commented out the dictionary. Don't worry, we might use it later on. Oh, I'm trying to build, and it's not building because my hands are empty. If I use 6, now I can build. Right, let's go and mine these and see if we get some collectibles. Right, mine you. Okay. Oh, I think I know what's happening. Nothing too bad. Missing one required position. We're not passing in the subject when we're instantiating or initializing our collectible. So we do that in the mining system. Inside mine, down there, drop a collectible. There we go. We need to pass in, after texture, we also need to pass in the subject. The question is, do we have a reference to the subject in mine? No, we don't. So when we mine, we also have to pass in the subject. So call that underscore sub. And now we can pass into here, underscore sub. And then we just need to go one level up. So what calls mine, that's in mesh terrain. And that would be in 2 places. That would be, or do mining. Yes, I remember. We made this function just in case this happened where we need to change some things. We only do it in one place. So mine, after texture, we want to pass in this dot. Have we got a subject reference? Yes, we do. There we go. This subject. That's in there as well. Okay, so jump back into the game, test it out. I've got nothing on the hotbar now. Right, I can mine. Okay, I can mine. And we're getting the correct block types. Do I have, yes, I've got some red, some green, and some snow, and some ice, put that over there. So 3. It's mining with some stone or whatever it is, snow, and some emerald, and some rubies. Great. Now can we mine these guys? Oh look! The colour problem is back again. That's disappointing. And confusing. Bet it works now. No, okay. So I'll find out what's happened. And in the console, oh, when I'm walking over them, we should get a console message about being in the correct place, if it's worked. Don't think it has. Can't build here, sorry, no. Got me, okay. So this lovely thing, doesn't work. So 2 reasons might be, well, they're vector 3s or tuples, and maybe here we're asking the question, are these the same variable? Is this the same data, which it might not be. Also, we might be, if that isn't the case, so we are comparing them, then maybe we're flooring one where we're rounding another. Let me show you what I mean. In mining system, in the highlight, look, we floor the Y, but we round the X's. And this is of, yeah, the BTE. So, our collectible system. So, let's generate this first. So, we want to round X and Y, X and Z, floor Y, then I don't know X, Y, Z. So now we're just generating that tuple. Oh, put bracket in the wrong place. Let's go and see if that. Oh, do we actually call that function? I think we do. From update, yeah, check pickup. Check pickup. Just making sure it is actually running. The code isn't actually fine, but just not running. some soil. I don't know why the colour's no longer working. Yeah, they've gone white again. What's going on there? How bizarre. Oh, look. That's exciting. It's detecting that we've got you. Okay. Oh, that's great. So, the problem was we're just not flooring Y, I believe. And this is now pretty clean, pretty simple. Okay. So what do we want to do instead of picking you up? We want to destroy this entity. And now that we haven't got a dictionary, we don't need to remove it from the dictionary. If we did, by the way, what we do is we just get hold of a collectible dictionary and we just call pop. And what we might need from there is the key to this object, which would be this position, which is a tuple. So I'll put that in there, and that would remove it from the dictionary. But we don't need to do that. So I'll keep that code just in case we do need the the collectible dictionary later on. But I don't think we need yet. Whoops. So that's remove me from the dictionary. But what we do need is to destroy it. So we write destroy this. And destroy is the Ursina function to destroy or delete an entity. So from Ursina, we'll add onto the end of its import list destroy. And that should be fine. That feels bad though, because we're inside of an object's like brain. It's saying, oh, if this happens, destroy yourself. And then it destroys. And then hopefully that all evaluates and the interpreter can find its way out. Okay. Use key to, oh, no, I'm not doing anything there. Okay. And we're not making a key anymore, so I can take that comment out. Right. Save the module, go back to main and run. Press G to stop. Right. The moment of truth. Oh no. So it doesn't like that. Oh no, look. Now it's trying to like rotate itself, but it doesn't exist anymore. Oh no. Okay. So this is terrible. This means I need to learn something new for how to delete an object from its own class. Okay, how could you do that? Well, we could just object-oriented programming is all about sending messages from one object, one class to another, and then here between modules and things. So what we could say is something like send signal to delete me. So we can say something like this dot time to die, time to rest. That's better. Time to rest equals true. And then something else could check that. And if it's time to rest, then it destroys this object. So now I'm feeling I need the the collectible dictionary back. Oh, here's another idea. Here's another idea. Let's just hold our horses there. Maybe we need, can I refer to its entity? No, it would have counted it as an entity, surely. Yeah. So yeah, just so you know, this won't work. Just had another idea. Every entity should have a disable function. Oh, didn't like that. Yeah, it has no attribute entity. But maybe an entity has a this dot disable destroy. Let's just try disable. I don't feel like this is as satisfying or as good a solution, if it works at all, as destroying the object from the scene. I think it's still somewhere and we could enable it again, so it won't be as efficient. Let's run over here to the corner because we're scared and do some mining down here. Lots of grass. I'm going to put some blue ice over there. Right, and let's mine something. And let's go and collect one of these. We just yoinked it up. I'm like Pac-Man. Oh, we could have the Pac-Man sound. Now this one we can't collect because we're not on the same Y. So you can just jump and Pac-Man him. Notice these are now blue. Oh no, that is correct because, sorry, these aren't coded in. The colours aren't coded in. It's only for red and green, which are not here. So I'll have to try those next time. Oh, but look, we can now grab our collectibles. That's fantastic. And so that means their update function shouldn't be running anymore, which we could go and test in the future. Okay, that's one kind of solution. Right, what is it? It's about 1 hour 20 this video. Oh yeah, by the way, right at the end of the video, I always notice I keep getting cut off. If you watch to the end, that is. So I'll make sure I just like sit there for like 10 seconds doing nothing, and then it'll cut off that 10 seconds and not me giving the final like goodbye, because you keep missing my goodbye, so I seem rude. And you deserve better than that. So I'll get to that. Right. So color bug for Ruby done, and then it's undone. Don't know what's going on there. Picking up behavior, kind of done. Let's go and do the sounds very quickly. Since I've got, right, first we need to record a sound. So I've got Audacity here. What sounds are they make? Oh, it's like the classic little pop sound, isn't it? Like, right, let's try that. Okay. Recording. Oh no, would you like access to my microphone? Yes. Can't have me laughing. Right. Control Alt Delete. Great. Okay, try again. Right, that's the sound. Play that back. That'll do. How do I delete that? Do I just do delete? Oh, great. Oh, apparently I'm a sound engineer. Look at that. It looks a little clicky, but there we go. I'll do a better one off camera, or keep this as a classic. Right, so we want to export that as an MP3, and we need to export this to general dev, my client gets, where are we, Python, Ursina tutorials, Meshcraft, and we're going to place this in the assets folder, and we'll call it, we've got sand, snow step, and things like this, so we'll call this pop. There we go, pop. So MP3, I'm sure we can keep all of this, and then export. Oh, red hen. That's me, done. Yeah, 2022. Okay. Well, it's very small, so that should be, is that done already? So if I go to main, and if I go to reveal in Finder, that should open up our project folder. And inside assets, I should have pop. Yeah, there he is, pop. Okay, so if I go back to main, oh, I'm in main, you remember that we have a stepping sound, and I load those guys here, look. So we just need to load that in our collectible system. So let's just grab that one as an example. Go to our collectible system, and we'll go up the top here. I guess I should put these inside the collectible system, but I won't. I'll put it there, and then I'll call that pickup audio. Now audio doesn't exist, so we have to take that from Ursina. Oh, we don't use destroy anymore, so we'll use audio. There we go to replace it, and it's not step.og, it is pop.mp3. Autoplay wants to be false, and looping wants to be false. So now we've got, so we're storing that sound in pickup.audio variable. You can call that whatever you like. I'm suffixing mine with audio, so I know it's a sound, but you don't have to. So, oh, when we create one, we want that to kind of pop. So, done, let's do it under done. We'll say make sound, make collection sound. Yes, sorry, just zoning out. What did I just call it? Pickup audio dot play. Now what we also want to do actually, oh okay, let's just let's just see if it works. Let's just go ahead. I was going to say we should check whether it's already playing. Oh no, it won't already be playing, will it? Because it can only happen once. It's not like the steps. Again, this is more sophisticated. We're using a class. Oh, wait a minute. It's working already. I've just realised I just placed that play in the initializer. So we've accidentally made ourselves a mining sound. So I want this to be in the pickup sound. Let's go and record some more audio since I'm so good at it. So Control A. What does Pac-Man sound like? It's kind of like whap. Okay. Whap. Sound engineering is fun. You should go and be a sound engineer. That's what I do. I inspire future generations of sound engineers. Export that as an MP3. Ah, we're in the right folder this time. So this one is going to be called pickup. Pickup. Again, red hen, brilliant. So that's done. So back in collectibles, we've done our sound engineering now. Can't minimize a window though. Back in collectible system, we don't want to play pickup audio. We'll call that pop audio. So this needs to be called pop audio. And we want to create, sorry, let's put that at the top of your window so you can see what's going on. Pickup audio will be called pickup, my little whap sound. Again, all those parameters, settings want to be the same. We don't want it to play, we don't want it to loop. Now all we have to do is go to, so make sounds, that's pop audio, inside check pickup, yes. Pick me up. Oh god, no. Pickup audio dot play. Fantastic. Oh, you know what? I just realised this is the same as the steps. We don't want to interrupt that one audio object. So it's not every. I was thinking for some reason that we had given every single block click. Oh, that's great. I've accidentally created a mining sound. Bit in the wrong place, really, but that's fine. Oh. I just realised I've turned down my sound, so you might not be able to hear that. So I've just turned up my sound. If this is too loud, you're listening on headphones or something, be careful. Okay. Well, this is brilliant. Oh god, what does it sound like if you blister mine? Nothing. So that's kind of the issue I was talking about before. We've only got one audio object. So if they're all like happening about the same time, it only happens once. Which is something I want for collecting, because we don't want it to sound really weird. Anyway, collecting behavior is happening. It's not interacting with our inventory yet to kind of like populate different items on here. And bizarrely, when I mine those guys, I'm not getting the correct color. Very good. I feel like, yeah, Pac-Man. Great. Okay, amazingly, those sound files will be on the GitHub repository because I'll upload those probably before the video's up. So you can enjoy those and replace them at your will. So yes, next video is going to be video 20. So to celebrate, we definitely need some more mobs in there, and what I'll aim to do is to get the inventory interacting now with our collectible system. We've done everything on the end of the collectible system. Right, as the panda jumps off the world, thank you very much for watching. Hope you enjoyed that, and I'm going to now awkwardly sit in silence for 10 seconds so that I don't get cut off again. Goodbye.